So, we're going to dive into a truly wild theory today, one that tries to solve two of the biggest mysteries in the entire universe at the exact same time, with one single violent event from the dawn of time. All right, let's start with a really big question, maybe the biggest one. Why is there stuff? Why are we here? Why is there a universe filled with matter at all instead of just an empty void? It sounds like philosophy, but for a physicist, it's a real head-scratcher. And get this, all the stuff we know and love, you, me, the stars, the galaxies, that only makes up about 5% of everything. A huge 25% is something else entirely, this invisible stuff we call dark matter. We can't see it, but we know it's there from its gravity. We just have no idea what it is. And that is mystery number 2. So, going back to that first mystery, the Big Bang should have cooked up equal amounts of matter and its evil twin, antimatter. Now, these two are sworn enemies. The moment they touch, they wipe each other out in a puff of pure energy. Logically, the universe should have just canceled itself out, leaving nothing. And yet, well, look around. We're here. Something must have cheated. Okay, so let's lay it out. We've got two huge cosmic puzzles on our hands. First, the case of the missing antimatter. Why did matter survive? And second, the case of the invisible stuff. What on earth is dark matter? The theory we're digging into suggests that the answer to both questions is actually the same. To crack this case, we have to turn the clock way back. We're talking the first microsecond after the Big Bang. The idea is that in this crazy, hot, dense soup, the universe went through a kind of hiccup, something known as a phase transition. Now, to get what that hiccup really means, we got to talk about something a little scary, the idea of a false vacuum. Picture a ball sitting in a small dip on the side of a huge mountain. It seems stable, right? But one little nudge, and it's all downhill to the real valley floor. The idea is our entire universe might be in a state just like that, a false vacuum. And if it ever got nudged, the very laws of physics could rewrite themselves instantly. And listen to how physicists describe this. It is not an understatement. Sidney Coleman and Frank DeLucia called it the ultimate ecological catastrophe. Yeah, it's not just bad for life, it's bad for chemistry. The fundamental rules of reality would just break. Seriously scary stuff. Okay, so that's the terrifying version. But what if a version of that cosmic violence already happened in the past? And what if, instead of ending everything, it actually started everything for us? So let's pinpoint the exact moment we're talking about. Just 1 microsecond after the Big Bang, the universe hit a critical temperature. The free-floating soup of quarks and gluons finally cooled enough to stick together and form protons and neutrons. This event has a fancy name, the quantum chromodynamics, or QCD, phase transition. Now, right at that moment, something really weird happened. This is our first major clue. The pressure in the universe suddenly took a nosedive. The sound speed, which is basically just a measure of that pressure, dipped hard. And why does that matter? Because with less pressure pushing outwards, the inward pull of gravity suddenly got a massive advantage. So we have a time and a place, the scene of the crime, if you will. The conditions were perfect for things to collapse under their own weight. But a collapse of what? Well, this is where our main suspect for dark matter enters the picture. Let me introduce you to primordial black holes. Now, these are not your everyday black holes. They're not made from giant, dead stars. No, these are the originals, the OGs, forged right out of the superdense fabric of the baby universe itself. And here is where it all clicks together. That cosmic hiccup we talked about, that sudden drop in pressure during the QCD transition, it created the perfect storm, the ideal recipe for black holes about the size of our sun to just snap into existence. Okay, now hold on, because this is where the theory goes from cool to absolutely mind-blowing. The birth of one of these primordial black holes wasn't a quiet little event. No, it was an explosion of unimaginable power, a primordial supernova. So what does that even mean? Well, picture it like this. A super dense patch of the universe starts to collapse. As it does, it sends out this ferocious shockwave, like a cosmic depth charge. That shockwave creates a bubble of insane heat and pressure. And inside that bubble, that's where matter is born. So you can basically see it happening here. A region of space collapses in on itself, forming the black hole. That collapse unleashes this crazy hot shock wave, and inside that furnace, the rules get bent just enough for matter to get the upper hand on antimatter. And then, boom, all that brand new matter gets blasted outwards to seed the rest of the cosmos. And we're not just guessing here. The physics predicts how hot these hotspots got. We're talking 5 tera electron volts. That's an absurdly high temperature, thousands of times hotter than the universe around it. And critically, it is way above the energy needed to break the tie, to give matter the winning hand against antimatter. This is it. This is the smoking gun. And this brings us right back to our 2 big mysteries. So, what's the dark matter? It's the primordial black holes that were left behind. And where did all the regular matter come from? It was forged in the fiery explosions of their birth. A perfect, elegant, 2-for-1 solution. Okay, that's a fantastic story, right? But in science, a good story isn't enough. It has to make predictions you can actually go out and test. And the best part is, this theory does just that. See, this isn't just some vague idea. It predicts something very, very specific. It says that if we could look at all the black holes out there, they shouldn't just have random sizes. There should be a distinct pattern, a fingerprint, left over from that primordial era. The theory predicts we should find a whole bunch of black holes right around the mass of our sun. It also predicts another little bump in the data, another popular size, right around 30 solar masses. Now here's the wild part. Our gravitational wave detectors, LIGO and Virgo, are finding a surprising number of black holes smashing into each other that are, you guessed it, right around that 30 solar mass mark. It's not proof, but wow, that is a very exciting hint. And there's more. The theory also neatly explains another nagging puzzle we call the cosmic coincidence. Why is there about 5 times more dark matter than regular matter? Seems kind of random, right? Well, in this model, it's not random at all. The physics of those primordial explosions naturally spits out that exact 5-to-1 ratio. It just works. And this quote just wraps it all up so beautifully. It explains why the matter we're made of is so precious, so rare. It's because the primordial supernova that created it were themselves almost impossibly rare events. So I'll leave you with this. What if the dark matter we've all been searching for isn't just some boring stuff floating around? What if it's the actual leftover engines of creation, the remnants of the very explosions that made us possible? It's an incredible thought that the thing we're looking for and the reason we're here to look for it are one and the same.